Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving real-world problems involving systems of equations. Let's look at our first example. In example 1, it says Ashley has 21 coins, which are all dimes and quarters. The total value of her coins is $3.15. How many dimes and how many quarters does she have? Now, the first component of solving any system of equations is to translate the phrases and sentences of our question into a system of equations. And in this problem, the system is written for you. And it tells us that the system is D plus Q equals 21 and 0.10D plus 0.25Q is equal to 3.15. So this is our system of equations. It's already been written for us. So in question 1, they want to know, what does the D plus Q equals 21 represent? So go back to that very first sentence where it says Ashley, whoops, I meant to do that in green. Ashley has 21 coins, which are all dimes and quarters. So the D plus Q equals 21 represents the total number of coins she has. Okay. Our second question says, what does the 0.10D plus the 0.25Q equals 3.15 represent? Well, to find that out, you're going to go back to the second sentence where it says the total value of her coins is $3.15. So this equation represents not the total number of coins, but the total value of her coins. All right. The next thing they want us to tell is, what does each variable represent? So the D in this problem represents the number of dimes she has, and the Q represents the number of quarters she has. Now, the question we're trying to find out is, how many dimes and how many quarters does she have? Okay, we know they have to add up to 21, but we don't know, does she have 10 and 11? Does she have 18 and 3? We don't know. Okay, so what we're going to do is we're going to write down the system here and write it on the left side so that you have some room to work. I'm going to say D plus Q is equal to 21, and 0.10D plus 0.25Q is equal to 3.15. Now, because both of these equations are written in standard form, I'm going to solve this system by elimination. So I have to eliminate either the dimes or the quarters. It doesn't matter which one we eliminate. So I'll just eliminate the dimes. And what I can do is, remember, when we're eliminating a variable, we have to have opposites. So I'm going to look at the D's here. And I'm going to make the top one negative 0.10. So to do that, I'm going to multiply everything in that top equation by negative 0.10. Now remember, you have to multiply everything in that equation by negative 0.10. So negative 0.10 times D is negative 0.10D. Negative 0.10 times Q is negative 0.10Q. And negative 0.10 times 21 is negative 2.1. Don't do anything to the bottom equation. Leave it just like it is. Okay. Now, notice that we now have opposites. We have, for our dimes, we have negative 0.10 on the top and positive 0.10 on the bottom. So if we were to add these two equations together, this would zero out. And when I add up negative 0.10 plus 0.25q, I get 0.15q. And then negative 2.1 plus 3.15 gives me 1.05. Now divide both sides by 0.15. So 1.05 divided by 0.15 gives me Q is equal to 7. So now I know the number of quarters. So to find the number of dimes, I'm going to take my top equation, D plus Q equals 21, and I'm going to plug in a 7 for the number of quarters and solve for the number of dimes. So subtract 7 from both sides. 21 minus 7 gives me 14. Now, let me show you how we can check our answer. We know the total value of her money was $3.15. So I had 14 dimes that are worth 10 cents each, plus 7 quarters that are worth 0.25 each. And that does add up to a total value of $3.15. So we know we have, oh my goodness, what did I do here? We know we have the correct number of quarters, which was 7, and the correct number of dimes, which was 14. All right, let's look at a second example. In example 2, a volunteer firefighters organization held a pancake supper as a fundraiser. They sold adult tickets and children's tickets. 345 people attended the breakfast, and $1,395 was raised. The cost of an adult ticket was $5, and the cost of a child ticket was $3. How many children's tickets were sold? So let's assign our variables first. We're going to let A equal the number of adult tickets, and we're going to let C equal the number of children's tickets sold. And in our first equation, they want us to write an equation representing the total number of people attending. So we have to go back to our first bullet point there, and it said 345 people attended. So I'm going to say the number of adults, A, plus the number of children, C, has to equal a total of 345 people. All right. Now the next thing they want us to write an equation for is the total amount of money raised. So we know that the adult tickets were $5 and the children's tickets were $3. So 5 times the number of adult tickets plus 3 times the number of children tickets has to equal a total of $1,395. All right. In the next box, they want us to put these together and write the system of equations. So A plus C equals 345, and 5A plus 3C equals 1,395. Now, in our last box, they want us to solve the system. Now, when you write the system, be sure to write it all the way to the left so we have room to show our work. So I'm going to say A plus C is 345. 5A plus 3C is 1,395. Now, let's look at what the question's asking again. The question says how many children's tickets were sold. So that means we don't need to know the adults. So if we don't need to know the adults, let's eliminate the adults and solve for the number of children. So here's what I mean by eliminate the adults. Look at your A's here. We have a positive 1A on top and a positive 5A on the bottom. I want to create opposites so that the A's will zero out or eliminate out. All right, I want to create opposites. So to do that, whoops, I wanted a pen, not a highlighter. To do that, I'm simply going to multiply everything in that top equation by negative 5. So that would give me negative 5a. Negative 5 times c would be negative 5c. And 345 times negative 5 would give me negative 1,725. Now, I'm not changing the bottom equation at all. And I can see that I forgot to put the negative on the 1,725. All right, now that you have opposites, draw your line and add the two equations together. So negative 5a plus positive 5a would zero out or eliminate. Negative 5c plus 3c would be negative 2c. And negative 1725 plus 1395 would give me negative 330. Now divide both sides by negative 2. Negative 330 divided by negative 2 gives me 165 children's tickets were sold. All right, example 3. A bus travels two different routes, the green route and the blue route. The routes are different lengths. On Monday, the bus traveled the green route 6 times and the blue route 5 times, traveling a total of 52 miles. On Tuesday, the bus traveled the green route 12 times and the blue route 13 times, traveling a total of 119 miles. What is the length of the green route in miles? So the B in this case is the length of the blue route, and the green is the length of the green route. Now we're going to write a system. So let's look at our first bullet point. On Monday, the bus traveled the green route 6 times and the blue route 5 times for a total of 52 miles. So I'm going to say 6, the green route 6 times. So 6G and the blue route 5 times plus 5B, and that equaled a total of 52 miles. On Tuesday, the bus traveled the green route 12 times, so 12G, and the blue route 13 times for a total of 119 miles. And we want to know the length of the green route. Now, in this problem, it's a lot easier to eliminate the G's because I have a 6 and a 12, and 6 will go into 12. So we're going to eliminate the G's and solve. All right, so let me write my system down again. But remember, keep it all the way to the left so that you have room to show your work. So 12G plus 13B equals 119. Now, look at your G's. I want to obtain opposites right here. So I want to turn that 6G into a negative 12G. So I want you to think to yourself about what you would have to multiply by. What would you have to multiply 6 by to turn it into a negative 12? All right, hopefully you said a negative 2. So I'm going to multiply everything in this top equation by negative 2. So negative 2 times 6G is negative 12G. Negative 2 times 5B is negative 10B. And negative 2 times 52 is negative 104. Don't do anything to the bottom equation. Now draw your line and add the two equations together. So negative 10B plus 13B is 3B. And negative 104 plus 119 is 15. So 15 divided by 3. So now I know the length of the blue line is 5 miles. But the question here asked, let me highlight this, what is the length of the green route? I know the blue route, but I want the green route. So what we're going to do, let me draw a line here for some separation, is I'm going to take either one of the equations. I'll just use the top one. 6g plus 5b equals 52. And I'm going to replace the b with a 5. So 6g plus 5 parentheses equals 52. Since I know the blue route is 5 miles, I can put a 5 in for the b. Now we're going to solve this for g. So 6g plus 25 equals 52. Subtract 25 from both sides. So 52 minus 25, and that gives me 27, and then divide. 27 divided by 6, and that gives me 4.5 miles. So the green route is 4.5 miles. That's our solution. All right, example 4. A drummer and a guitarist each write songs for their band. The guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. They wrote a total of 46 songs. How many songs did the guitarist write? So I'm going to let D equal the number of songs by drummer, and I'll let G equal number of songs written by the guitarist. All right, now I'm going to highlight where we're going to get our equations. So we know the guitarist wrote 8 fewer songs than twice the number of songs the drummer wrote. And we know they wrote a total of 46 songs. So let's start with what's highlighted in green. The guitarist wrote, so they said guitarist first, so I'm going to put G equals 8 fewer than twice the number of songs that the drummer wrote. Now I always put my variable first, so twice the drummer would be 2D, and 8 fewer than that would be minus 8. So there's our first equation. Our second equation comes from the highlighted pink area. They wrote a total of 46 songs. So the number of songs written by the guitarist plus the number of songs written by the drummer has to equal 46. Now, in this problem, both equations are not in standard form. So you would not want to use elimination in this problem. In this problem, one of the equations is solved for G. So we would want to use substitution, and I'm going to write that down, just abbreviate that. Because the reason we're using substitution, let me say it again, is because the equations are not both written in standard form. All right, so remember to use substitution. I'm going to take my second equation, G plus D equals 46, and I'm going to replace the G with the expression 2D minus 8. So blank plus D equals 46. And I'm going to plug in the expression 2D minus 8. Now we're going to solve this for D. So we'll combine like terms. 2D plus 1D is 3D minus 8 equals 46. Add 8 to both sides. So we get 3D equals, 54? Divide 54. Divide by 3 gives us 18. So we know that the drummer wrote 18 songs. But let's go back and look at what the question asked us to find. How many songs did the guitarist write? So we don't want to put that 18 for our solution. We can use it to get our solution, but it's not our actual solution. So I'm going to take my equation, G plus D equals 46, and I'm going to replace the D with 18. So G plus 18 equals 46, and subtract 18 from both sides. 46 minus 18, and that gives me 28. So our solution, the guitarist wrote 18 songs. And I'm seeing now I left one of my boxes blank. I was supposed to write the system there. It was G equals 2D minus 8, and G plus D is equal to 46. And that concludes today's lesson, solving real-world problems involving systems of equations.